who are you? My name's Anna Benzel. Welcome back to my channel. We are going through these LeetCode problems, and this is problem number 62, unique paths, and my solution here is done in Python. Again, not quite sure why I didn't save here, but we have a submission from, I think, the 15th? Yes. Okay, so this is my submission from the 15th. As you can see here, I only beat... Oop. That video finished downloading. I only beat 22% of users in Python with runtime, but on memory, we're cruising at a solid 96%. So let's get into this code here. This is my solution. And I basically just did this solution using dynamic programming to calculate the number of unique paths from the top left corner to the bottom right corner of a grid. And if you guys want to, I'm not sure why this is not closing, but you guys are more than welcome to read this question on your own time. But that's just basically a loose summary, or that's not even the full summary. In this particular one, we built out a 2D array where each cell basically represents a number of unique paths to reach that cell. And it fills the array iteratively. Sorry, I have a cat here. Based on the relation. So let's jump into this first line here. We initialize this 2D list that this DP or dynamic programming with the dimensions for the rows M and then the columns N. So N and M. Each of those cells in the grid is initially set to 1. And that is just essentially done so that there's one unique path to reach any cell in the first row or first column, which is basically by moving either right or down. We then jump into this nested loop here, which iterates through the rows, which is I in this case, and the columns, in this case it's J, of this DP grid, starting from the second row, which is row 1, and the second column, which is then column 1. So this for I in range IM that iterates over the rows, and then the for J in range 1N that iterates over the columns. So that is just this sort of loop and how I approach this, which I do think is what, and I'm not entirely sure, but I think that is part of the reason the runtime for this was so bad. So digressing in there, we just calculate in this loop the number of unique paths to reach that cell, and it continues until the DP list is filled with the number of unique paths to each cell. So we just return the value of the bottom right cell of that DP grid, which just represents the total of the unique paths to reach that destination, which is, for this particular question, the bottom right. So I hope that makes sense to you guys. I do want to rework this at some point just because this was really low, but I feel pretty good, obviously, about the memory. But I have this code in the GitHub repo link in the video description down below. You guys are more than welcome to fork and clone. Make it better, make it worse, have some fun, learn something new, and I will see you guys in the next video. Thank you so much for watching. Goodbye.